Hello and welcome back to our journey through the solar system. Today we are visiting another dwarf planet. Like Pluto and Makemake, Makemake is a dwarf planet that's located in the Kuiper Belt. Makemake is named after the Rapa Nui god of fertility. This is the indigenous people of the Easter Island. This follows the IAU guidelines for trans-Neptunian objects to be named after mythological beings associated with creation. This was also chosen in part because it was actually discovered near Easter, and the team called it Easter Bunny as a nickname. Makemake was discovered in March of 2005 and announced in July of that same year. It was actually announced a little sooner than was planned because of all of the drama surrounding Makemake in this July of that same year. Because Makemake was discovered by that same American team led by Mike Brown. So following this discovery in 2005, it was confirmed by the IAU as a dwarf planet in 2008. Although Makemake is very bright, it's actually the second brightest object in the Kuiper Belt after only Pluto. Because of its very high inclination, it's not located near the ecliptic, which is where most searches for minor planets take place, and that's why even though it's such a bright object, it took so long for it to be discovered. But after its discovery in 2005, astronomers were able to go back and pre-cover it in data as old as 1955. And it's actually bright enough that it could have been seen during the search for Pluto in the early 20th century, but again, it wasn't in the right location. Makemake has an orbit that's pretty similar to those of Pluto and Makemake. That is, it's located beyond Neptune and in the Kuiper Belt, and it's very eccentric and inclined. It orbits at a semi-major axis of about 45 AU, which is about 1.5 times as far out as Neptune is. And Makemake is what's considered a classical Kuiper Belt object, which means it's actually not controlled by a resonance with Neptune. This makes a year on Makemake over 300 times longer than a year on Earth, and it takes the sun's light 6 hours to reach Makemake. It has an eccentricity of about 0.16, which means it gets as close as 38 AU to the sun and as far as 53 AU during the course of its orbit. In fact, Makemake is currently very close to aphelion, that is the furthest point in its orbit from the sun, and it's going to reach aphelion in 2033. Its inclination is quite high as well. It's almost 30 degrees inclined to the ecliptic, and again, this is one of the reasons it was so difficult to discover. Now, Makemake is just too far away and too small to be observed in very much detail. So one tool that astronomers can use for these kinds of small bodies is something called a color index. So a color index is just the difference in magnitude when observing through different color filters, usually B, V, R, and I, that's blue, violet, red, and infrared. So Makemake has a color index that indicates it's rather red, and this is actually very similar to Pluto's color index, and so Makemake might have a surface pretty similar to that which we've seen in quite a lot of detail on Pluto. Scientists can also use spectroscopy to get information about the surface and composition of Makemake. And in this case, they've detected abundances of methane and ethane, but actually not as much nitrogen as Pluto has. Another tool that we can use in these small bodies is how the light changes over time. This is called the light curve, and we saw with Makemake just how much information that can give us about a body. But in fact, Makemake's light curve is actually not that informative. It's very spherical, unlike Makemake, and it's spinning very slowly, unlike Makemake. In fact, it has a day that's almost similar in length to an Earth day. And the change in brightness over time is very small, which at first scientists thought indicated we're actually looking at the pole of Makemake, because you can imagine that if you're looking at the pole, then what you see doesn't really change as the object rotates. However, now they realize that we are in fact looking more at the equator of Makemake. It just doesn't have very big variations in its magnitude as it spins. And in 2011, Makemake passed directly in front of a star. This is called stellar occultation and can give us a lot of information about the object, including its physical size. So astronomers were able to use this occultation to actually measure the size of Makemake and to detect that, unlike Pluto, it actually doesn't really have an atmosphere. And then in 2015, Hubble observations of Makemake uncovered a moon for the dwarf planet. Now this moon is called S 2015-1364721. And the reason it doesn't have a cool, fun mythological name yet is because it's actually just a provisional moon. This means it hasn't been confirmed yet because that observation was the only time that it's been detected. And astronomers think one of the reasons it's been so difficult to detect is that we're actually seeing its orbit almost edge on. So it spends most of the time either in front of or behind Makemake, making it very difficult to detect as its own object. But once it is officially confirmed, it will get a cool fun name. And because this moon has only been observed once, we really don't have a great idea of what its orbit is, which would allow us to really precisely constrain the mass of Makemake. So instead we just have an approximate mass for Makemake. We think it's about 2,000 times less massive than Earth, so very dwarf. Interestingly, while Makemake itself seems to be very bright and icy, just like Pluto and Haumea, its moon seems to have a reflectivity that's more like charcoal. Now, being even further from the sun than these other dwarf planets that we've talked about, Makemake probably isn't in line for an in-situ exploration mission anytime soon, but of course we can always hope, because I know that we would learn so much if we visited more of the dwarf planets in our system. Now, Makemake may not be as flashy as some of the other dwarf planets, but it's still a really important part of our solar system. It's added to our understanding of small bodies in the solar system. And it's an amazing dwarf planet in its own right. I just wish we could know a little bit more about it, but it's just so small and far away, it's really challenging. But thank you for joining me on our journey to Makemake today, and I hope I will see you again next time. Have a good one. Bye.